Okay, now I've disassembled the cutter, and I've got the cutter to this point where all your connectors are here. Now when you go to work on this thing, before you slide everything back together, this is a way for you to plug everything in and do all your tests and your leads. If you can see, I got my rotations turning here. I got my other rotation here. Now you can note down inside here there's a little Lovejoy, and I'll get up a little closer to show you what I've done there. Some of you guys that are familiar with taking it apart, there is this little wiring schematic that you can get. I can send you a picture of it. I got a bigger detailed drawing of the wiring schematic for the cutter and some notes. Again, I could probably help some of you through their conversation. I mean, if you give me a call. Now what I'm going to do, I covered the back end of the cutter. Okay, I'm going to bring this up a little bit closer. If you look right here, you can see this little Lovejoy that I put in here. This is what you call a solid Paraflex coupler. On my rotation, there was a need to put that in there to take that mechanical clutch that was in there out of there. I could not put a Lovejoy there because it would take that rubber bushing and it would take and turn that rubber bushing and mash it. So I had to put a solid coupler right here, okay? You can see I put the Lovejoy in here. It's on the slide. I put the Lovejoy right in here. It's on the slide. What that does, again, I'll tell you, it sets up a cushion program. I have an internal clutch with the scissor lift head, so there's no need to have the clutch inside the cutter. On the rotation, there's no need to have a clutch there on the rotation either. I mean, if you wanted to leave the clutch, if you're not running a current limiting controller, I know Aries has one out there. I've made some changes on the voltage program on that in order to make my head run better. They had 2 voltages in that cutter. We're running at about 43 volts, and there was another one running at 29 with a different relay in there. All of them motors can handle that 43 volt DC. If they got it on 2, they're all the same Globe motors. That one will also handle it, and that's how I made the power come out of that head assembly. Again, I can tell you how to do that. We all know what the price of these little motors are. Now, Globe Motors has been out there for a long time making motors for Aries Industries. They've been making them for Tom Bowman and Tritech. I know that Tom is making his own motors now. He came out just before the show, a couple weeks before the show. He had them down at the show. I don't know the longevity of the motors. I can tell you what I've done to the motors to make it work. I see Tom looks like he's still got a hardened shaft in there. Every single one of you have got motors, I'm sure, where you've busted the end shaft off of the motor. And if you see what I've done, I've taken this end shaft, which is 250 thousandths, okay? This is a hardened piece of steel. This is the original. And then they put a little snap ring groove right in there. Well, that brings that down to 220 thousandths diameter, about 3/16 of an inch. With any shock at all on that rotation, it would snap this shaft off. When I changed it over to chain drive and we got the heavy-duty head assembly in there, I took this unit and made one out of stainless steel. I went to 375 thousandths in diameter right here, and then I went to a 5/16 diameter here. So now we stepped it up, and I put the snap ring groove at the 375. I also left this piece of 4/16 stainless steel soft. It's got hardened gears within there. You got soft gears here. There's no way that it'll gall up at the rotation RPMs of that motor. That's 2 RPMs that thing is turning at. There's no way that that's ever going to gall up with inside that motor. That way I could broach straight through there, and I got a 5/16 shaft that you see coming through here like so, and they both got a keyway in there. Okay, with that Paraflex coupler, when you slide that over there, you take these set screws that are right here, and you can tighten them up. That thing is one with each other. It cannot shear the shaft, and it cannot roll the half moon keys. I know you've all seen that. A lot of the little couplers used to have a set screw that would just push on the key, and that thing would start working back and forth, and it'd roll that key over. There is some changes that need to be done on this piece of stainless steel. That's why you have to send the cutters in to me. If I wish that I could just send you a kit out with this video, you'd be able to put it in there, but you're not going to be able to because there is a little bit of machining that has to be done on the cutter. Everybody's out to sell everybody brand new cutters in the industry. I've given you the opportunity with what I've done with this chain drive, the seal kit, for the first time to take a cutter that you spent $15,000 on, send that to me for $3,500, and rejuvenate your old piece of equipment. Now that's going to only happen at $3,500 if you send me a cutter that has 3 quality motors. We all know that them motors are about $1,100 a piece. I would really like to entertain the thought of trying a couple of Tom's motors. They're brand new out there. I think it's phenomenal that that man has built his own motor just due to the fact of what these small electronic motors are costing in the industry. I'm going to try to talk to him in the next few weeks and see if we can't come up with a program. But that's pretty much what you're seeing, what I've done with the cutter. I'm having fun in the industry helping you. I would hope that after this video that all of you would give me an opportunity to show you some of what I've done over the past 4 years. I believe that I can help you save money within your cut.